So the project we are working on is about a soil erosion study. So basically the dust collectors collect particles of dust that get blown across the soil surface. Each particle will land in the Sutton collector where the wind picks up. So they're at different heights, and the reason why they're different heights is so they can take the dust out and see what types of particles actually go in those collectors. The collectors collect the dust, and then we weigh them to identify how many particles are at different heights. So basically, we're looking at the erosion. So basically, different particle sizes of sand will bounce across the surface, eroding the soil, and then these particles will land in either one of these collectors. Most of the soil will land probably in the lower collector, and then the top ones get very minimal. But basically, how soil erodes is small particle pieces of soil or of sand bounces across the surface, and actually that's what erodes the soil, not the wind. It's actually the sand hitting the ground, chopping away at the ground surface. So that's what makes erosion. We have an upwind section, so all the wind comes from the southwest direction, usually here in southern Mexico. And the upwind is going to be closer to the prevailing wind direction, so southwest. And when the wind blows, we wanted to take the top portion, the upper portion, and do the treatment on that, and then have the lower portion not treated at all, to see how many particles flow from the upwind into the downwind portion. There's collectors in the upwind and downwind. So the treatment we do in the upwind is removing the vegetation. So we have 4 treatments and 1 control. Control meaning do nothing to, just to have a standard. So the first one is treatment 4, which is completely removed of all vegetation besides the shrubs, like the mesquite or the yucca. And then the third treatment is 75% removal from the original, that is, the original cover. So we do transect lines also, the vegetation transect lines, LPI, canopy gap, every year to determine how the plants are progressing throughout the year and if we need to remove them or not. In general, we have more soil particles moving, we have more erosion. Throughout the years we've seen, just the years I've been working here, we've seen a drastic change of the horizons, the soil horizons, so the A horizons and the B horizons. They're important because there are certain nutrients and microbes that live in those different horizons. The soil still has enough nutrients to have the plants that need to be removed. Also, the amount of soil that's still moving. It's amazing how much soil is still moving. Some of the collectors, I don't know how much they hold in general, but we've had some of the upper collectors in the upwind section, the lower ones, completely full, like spewing out the top. So at that point we have to dump them because we don't know what's been lost. Yeah. But it's amazing how much soil, for some windy seasons, like this windy season wasn't as much. Windy season is usually in March. But we've had some windy season where they've just completely filled up the collectors. So that's pretty spectacular. After being the study being here, I think it started in 2002 by some master students. So being there that long and still having a lot of soil moving is pretty incredible. Well, as we noticed from the Dust Bowl, these things are really important, especially for agriculture, for tilling your fields, planting crops. These things are really important. If you can lose a good A horizon, B horizon, which we talked about, removing the plants off the surface. So if you have bare black soil through the farming, you're going to lose that good soil for actual crops to grow. So it's important to know how to crop and how to till the soil so you don't lose that special soil that keeps all the nutrients for the plants. So it's important to do no-till. It's important to know when you're not going to till during the windy season. That's silly. You know, it's important to know when. And these different studies can help farmers, can help different developers too, like industrial developers when they're building new buildings and things, when to not dig through the soil and when to actually start building.